Bismillahirrahmanirrahim. My name is Muhammad Taimour and you are watching my channel Taimour Khan. So as we know that in the previous lectures we discussed about how to find the unknown reaction for a given beam. So we used two methods for finding the unknown reaction for the given beam. The one method is prolonged, and in that procedure we use three equations of static equilibrium to find the unknown reaction for the given beam. And the second method was a little bit shortcut and tricky, which was based on the formula. So we used two shortcut formula and we found the unknown reaction for the given beam. And now let's consider that we are given a beam which has a support Ra 1.6 Newton and Rb is equal to 2.4 Newton, which is already known. So we already found out these two values in the previous lectures. So you should also watch those videos, and the link of those videos are given in the description. So this diagram is called load diagram, and we will use this load diagram to find out the values of shear force diagram, and then we will be able to draw the shear force diagram. For this purpose we will draw a reference line O dash, and this reference line will be aligned to the load diagram, because this reference line, this is a base for drawing the shear force diagram. And then we will drop three dash lines from the load diagram on the reference line, and these reference lines shows the position of point load and reaction, both the reaction on the reference line. Let's say that this point is Q and this point is C. Now we know that the load diagram starts from A and ends at B. So, and the corresponding position to A point and the reference line is O. So we will start from O. So here we see that the value of reaction at support A is equal to 1.6 Newton. So it means that this reaction is applying upward. So in the upward direction we always assume the values positive. So it means that 1.6 Newton is applying upward. So that's why we will consider this value as positive. Now the second thing which you should remember, that the reference line is the boundary between two types of values. The one is positive and the other is negative. So the positive value will always be drawn above the reference line here, and the negative values will be drawn here below the reference line. So let's start from point O. So the reaction value is 1.6 Newton and it is positive. So that's why let's say that 1.6 Newton is located here above the reference line, and I mentioned the word above because this value is positive. So now join these 2 points, so we will get a straight line. Now we see that there is no load between the point A and point C in the load diagram. So that's why we will join these 2 points, and it will give us a straight line which will be parallel to the reference line. So it means that when we draw a parallel line in the shear force diagram to the reference line, so it means that there is no load between these 2 points. So here the value of this point is also 1.6 and it is positive value. But at the same time, if we see in the load diagram, so the concentrated load has the value of 4 Newton and the load is acting downward. So it means that the 4 Newton value is negative. So we will add this minus 4 to 1.6 and we will get, so here we will add minus 4 as it is acting downward, so therefore I assigned it negative, and plus 1.6, so it gives minus 2.4. The result is minus 2.4, which is also a negative value. It means that this value is also located below the reference line. So let's assume that this value will be located here below the reference line, and this point value is 2.4, but here I will not mention it as negative because as its location shows that this value is below the reference line, so that's why there is no need to put negative sign before this value. So I will join these two points, so it will give us straight line just like this. Now we see in the load diagram that there is no load between C point and B point. So again I will draw a straight line parallel to reference line. So at this point the value is 2.4, but this is negative value. So I will write minus 2.4 here, and at this point the value of reaction is 2.4, which is positive because the reaction is acting upward, so that's why its value is positive 2.4. so both are cancelled and its result is 0. Now the 0 is located above this point here on the reference line, so it means that I will join these 2 points. So the diagram has been closed. This rectangle shows positive values and this rectangle shows negative values. So this is the required shear force diagram. Now for bending moment diagram I will use shear force diagram, and as we know that bending moment diagram depends upon on the area of the shear force diagram. So for bending moment diagram I will draw a reference line which will be aligned to both the above diagrams, load and shear force diagram, P and P dash, and I will draw 3 dash lines from O on P and Q on T and O dash on P dash. So dash line is only for the accuracy purpose, that every point should be drawn at its exact position. We know that the area of shear force diagram gives us the value of bending moment diagram. Now you should keep one thing in mind, that you should also keep in mind that we draw the shear force diagram from load diagram, and then we will draw bending moment diagram from shear force diagram. So it means the shear force diagram depends upon load diagram, and bending moment diagram directly depends upon shear force diagram. So if the shear force diagram is 1 degree, so it means that bending moment diagram will be 1 degree greater than shear force diagram. So let's see that in this diagram the degree of this line is 0, so it means that shear force diagram is 0 degree. So shear force diagram is 0 degree. Here the lines are also 0 degree, so it means that this shear force diagram is entirely of 0 degree. So it means that the bending moment diagram will be 1 degree greater than this diagram. So the bending moment diagram will be of 1 degree. Now we see that this is a rectangle which start from O and ends at Q. So the distance from O to Q is 6 meter, and here it is mentioned in the diagram, and the total distance is 10 meter. So it means that this side of the rectangle is 6 and this side is 1.6 Newton. The rectangular area we multiply length multiply by width, so 1.6 multiply by 6, so it gives 9.6 Newton. So it gives 9.6 Newton dot meter. Every point located on the reference line has the value 0. Let's say that if I consider this point, so it means that this value is also 0. But if I consider this point, it means that this value is also 0. But if I move towards upward, so it means that I am increasing the value. 9.6 value will be located here, somewhat here. So it means that its value is 9.6 Newton dot meter. Now join this point to P point. So we will join it with the help of a straight line, and the straight line shows that this line is up 1 degree, and this drawing justifies that this is 1 degree greater than shear force diagram. Now this value is 9.6 Newton dot meter and this value is positive, but look at this rectangle. So the area of this rectangle will be negative because this rectangle is below the reference line. So the area of this rectangle will be length multiplied by width. The length is 4 meter and the width is 2.4 Newton. So by multiplying 4 multiplied by 2.4, so it means that it gives 9.6, but I will put a negative sign here because this rectangle lies below the reference line. So by adding this value with this positive value, so we will get 0. Both the values are same in magnitude, but their signs are different. So that's why the result is 0, and the 0 is located here. So it means that when I join these 2 points with the help of straight line, it will complete our bending moment diagram. Word shear force diagram, and this diagram shows the bending moment diagram. Thanks for watching. Thank you.